Alright guys, welcome back. We're going to be talking about proving that figures are similar today, so working with similar figures. Our learning target is going to be to explain the effect of dilations on two-dimensional figures. Specifically, we're going to be dilating towards the end of our sequence. Okay, so we may do reflections, we may do rotations, and we may do translations, but we're going to end up dilating at the end to show that the shape has gone from moving around the plane and being congruent to then becoming similar. Our success criteria for this is going to be first to find the scale factor for a given pre-image, an image on the coordinate plane, and then we're going to do lots and lots of describing, okay, the effect of a dilation on the image. And we're also going to add on the other rigid motions. So not only are we going to be describing the dilations, but we're going to add the other rigid motions as well. Remember, when I say rigid motions, those are the ones that don't change the size. So translations, reflections, and rotations. So the main idea here for this is a two-dimensional figure is similar to another two-dimensional figure if you can map one figure to the other by a sequence of rotations, reflections, translations, and dilations. The moment you dilate, you have now created similar figures. If you don't ever dilate, you're only creating congruent figures. The symbol, the little squiggle, that means is similar to. So we can actually say in this diagram right here, the similarity statement, okay, similarity statement. So if a test question asks you to write a similarity statement, this would be kind of what they're looking for. We can say A, B, C, D is similar to A prime, B prime, C prime, and D prime. Okay, now I want to discuss with you this particular picture here. It's kind of showing you in the grayed out dots where A, B, C, D has moved from spot to spot. So it looks like the first movement that A, B, C, D made was a translation 6 units left and then 1 unit up. And this is where A went to. And you can tell that all the rest of the points did the same thing. So 6 units left, and then 1 unit up for B. 6 units left, 1 unit up for C. And then 6 units left, 1 unit up for D. They're not showing the multiple rectangles because they just want to show you this is where we started. I'm going to write that in red. Okay, so this was the starting figure, or the pre-image, and then this one is the image. But there were many steps in order to go from the start to the image. So, first off, there was a translation. Then from there, it looks to me like in order to get what I've written in red down to be in this second quadrant, it looks like a rotation of 90 degrees. So if we rotated 90 degrees, that means that B is going to travel along this circular arc. A is going to travel along this circular arc. D is going to travel along this circular arc. And then C is going to travel along this circular arc. Okay, so then the next step, because now I'm kind of looking at the end result, is I see now a reflection, because I see D is in the top left, whereas D prime over here is in the top right. So what I can do now is reflect the points that I have so far, which would put C right there. It would put, let's see, D is 4 units away from the y-axis, so D would be here. Okay, and we can see those grayed out points. B would be here, and A would be here. Then lastly, they do the dilation. So the first step, translation. Second step was the rotation, then the reflection, and then finally a dilation. We did a combination to go from the pre-image to image of all 4 different transformations. And that may happen in different examples that you may have. You may have to move the shape multiple times in order to go from start to finish. So let's take a look at this first example. It says, given triangle ABC is similar to triangle NOP, describe a sequence of rigid motion followed by a dilation with center 0, 0 that maps triangle ABC to triangle NOP. So let's break down what these instructions are actually asking us to do. They say describe a sequence, okay? That means we're going to describe multiple rigid motions. Okay, rigid motions are going to be translations. Okay, I'm going to blow that up here a little bit so you guys can see what I'm writing. Reflections or rotations. Okay, any one of those 3 are going to be the rigid motions. Okay, then it says follow it, or follow those, okay, could be one of them, 2 of them, or 3 of them. Follow those rigid motions with a dilation. That's going to create the similarity in the 2 figures. Now, the last part of these instructions are that it maps triangle ABC to triangle NOP. That means we're going to be moving triangle ABC. Whoop, there we go. Okay, we have to make sure we understand that, because if you move NOP, the series of movements might be different. Okay, it might be backwards, or it might be just completely different altogether. So we're going to move ABC to sit on top of NOP. Now, the first thing you want to do is you want to line up wherever you're going to be dilating from. Now, it says center 0, 0. What I notice about where NOP is O is right on top of the origin. What that means is when we dilate, we want to put B on top of O so that when it dilates, B doesn't move and it still sits on top of O. So I think we should translate this figure first so that B specifically sits on the origin. Okay, so we're strategically picking a rigid motion of translation to get B to line up on top of O. And the reason for that is I don't have to reflect, I don't have to rotate, because I can kind of tell that these triangles are oriented the right way. A is supposed to be corresponding to N, and A is in the top left corner, so is N. C is in the bottom right corner, so is P, and those 2 are supposed to correspond. So since it's already kind of tilted the right way, it doesn't look like they're mirror images, and it doesn't look like it's been turned in any way, all I need to do is translate B to sit on top of O. So what that looks like is I've got 1, 2, 3, 4 units, and that was up. So that's a positive 4, and then we moved 2 units to the right, so that's a positive 2. So the first description I'm going to make is that we're going to translate, don't mean to be changing the size on you guys. We're going to translate 2 units right and 4 units up. The translation notation for this would be x comma y goes to x plus 2, y plus 4. Okay, so now let's actually move the shape. Okay, and I've already shown where B prime is going to go. And I need to move C the same way. So I need to go right 2, up 4, or up 4, right 2. Same thing. Okay, so I'm going to go up 4, right 2. That's where C prime goes. And then up 4, right 2. That's where A prime goes. Okay. So now that I've moved the shape, where B prime is now sitting on top of O, I can dilate. I can make this triangle to be, well, I'm going to have to figure out what the scale factor is. Do I want to make it half of the size, a quarter of the size, or a third of the size? I don't know. Okay, so we need to observe the side lengths. What I'm noticing about NOP is that from O to P, this distance right here is 2 units. But then if I look at the corresponding side on the bigger shape, A prime, B prime, C prime, from B prime to C prime, this distance is 4. And in order to get the scale factor, we learned in the dilation lesson that the scale factor is calculated by taking the image length and dividing it by the pre-image length. Okay, so the pre-image in this situation is A prime, B prime, C prime. And I know we usually say that the image is the one that has the primes on it, but we're trying to move A prime, B prime, C prime to sit on top of NOP. So NOP is really the image right now, and A prime, B prime, C prime is the pre-image. So I really want to do 2 divided by 4, which when we reduce, both 2 and 4 are divisible by 2, which means this ratio becomes 1/2. So I want to dilate with a scale factor of 1/2. I want to make the blue triangle, A prime, B prime, C prime, to be half the size. So that's what I'm going to write in my description. The first description I had was to translate 2 units right and 4 units up. The second description I have is then we're going to dilate by a scale factor of 1/2. And there we go. If you were to take all of the coordinates, A prime, B prime, and C prime, and multiply them by 1/2, you would obtain N, O, and P. Okay, let's actually look at that. A prime right now is at -2, 4. Okay, if I were to cut -2, 4 in half, I would get -1, 2. Well, that's exactly where N is sitting. N is sitting at -1, 2. So it looks like we did a good job. We translated the figure over, and then we dilated it down to sit on top of NOP. This description right here that we wrote, this is the proof. That is the proof. If you need to prove that 2 triangles or 2 figures are similar, you need to write a series of transformation. We have a series. We have 2 different transformations here, translation and dilation. That is the proof. That proves why these 2 figures are similar. So let's have you guys give this a try. Went one too far. Let's have you guys give this a try in your U-Try. Alright, I'd like to extend the idea that we just practiced, and I want to know, does a given translation followed by a given dilation always map a figure to the same image as the same dilation followed by the same translation? In short, what that means is, can you change the order of a translation and a dilation both being done to the same figure and end up in the same spot? So I've plotted down 2 triangles. I want you guys to plot these triangles down as well. A is at 2, 2, B is at 7, 3, and C is at 5, 6. Plot them down on both graphs, and then I'm going to give you the instructions I want you to follow for each one. Let's have you guys translate the graph on the right. We'll do 4 units left, and let's go 4 units down. Then we'll dilate by a scale factor of 2. Okay, and remember, sometimes I like to abbreviate scale factor. Okay, so then over here on the right side graph, we're going to swap the order. Okay, so you're actually going to translate the left graph, then dilate it. And on the right, I want you to dilate first. Same scale factor. Then we're going to translate. And it's going to be the same translation. 4 units left and 4 units down. So when you do both of these transformations, all I want to know is, did the image land in the same spot for both of these graphs? Alright, in the second example, ABCD and EFGH are rectangles. Given ABCD is similar to EFGH, we're going to describe a sequence, so multiple transformations, followed by a dilation with center 0, 0 that maps ABCD to EFGH. So first, let's take note of which one we're moving. It says we're going to map ABCD to EFGH, so we're going to be moving ABCD. It's also good to maybe take notice of what the scale factor would be, even though we're going to dilate at the very end. That might help you position the rectangle a little better. I'm noticing that from A to B, that's going to be 6 units, and from G to H, or oops, actually AB corresponds to EF. So the distance from E to F is 2 units. Okay, so the way that we got our scale factor was that, I'll remind us again, scale factor is image length divided by the pre-image length. Okay, well, the image here is going to be EFGH because that's where we want it to move to. We want to move from ABCD. So ABCD is the pre-image. So that was a length of 2 over a length of 6, both which are simplified by dividing by 2, and we get that the scale factor is 1/3. So the smaller triangle is 1/3 the size of the bigger triangle. So now I'm going to start trying to orient the larger rectangle in a way where I can get, after I do any of the rigid motions like reflections or translations, I can just dilate at the end and it'll sit on top. So let's just notice the vertices so that I can see maybe how I'm supposed to move this triangle. The similarity statement says that A is supposed to correspond to E. So I'm going to put a circle around A and a circle around E. I also see that B needs to correspond to F. So B I'll put a box around, and F I'll put a box around. C is supposed to correspond to G. So we got C and we got G. And then the last one is H. We'll just do like an underline. H corresponds to D. So right now, with the shapes and the colors kind of trying to tell me how I'm supposed to orient this, kind of looks like it needs to flip. It needs to reflect over some sort of vertical line. So I'm going to reflect A, B, C, D, let's say over the y-axis. Okay, so that's going to be my first movement. Reflect A, B, C, D, oop, that's another C, over the y-axis. Okay, now let's actually do that so that we can see what else we would have to do to get A, B, C, D to land on top of E, F, G, H. Alright, so A is 2 units away from the y-axis, so we got to go 2 units in the opposite direction, which is right there. There's A prime. D is 5 units away, so D is going to fall off the graph a little bit. And if that happens, you could, instead of reflecting over the y-axis, reflect over something else where it won't fall off of the grid. In fact, let's do that. You're working in pencil, so use that eraser, okay, because I don't like that I'm going to be falling off of this grid. Instead of reflecting over the y-axis, we're going to reflect over this line right here. I'm putting it in dotted. Now, if you remember how to name that, we name it as what axis it passes through. So this passes through the x-axis, and then we have to think of what number it's passing through. It's passing through 1. So this is the line x equals 1. So instead of reflecting over the y-axis, let's reflect over x equals 1. That's going to keep us inside the grid that they gave us. So now let's do this one more time. From the dotted blue line that I drew on this picture, A is 1 unit away. So I got to go 1 unit away in the opposite direction. There's A prime. D is 4 units away from the dotted blue line, so I got to go 1, 2, 3, 4 in the opposite direction. Okay, and then B and C are kind of the same. There's B prime and C prime. So far, having reflected over x is equal to 1, that is where my rectangle goes. Now, because the line, the right side of the rectangle is sitting on top of the y-axis, I can now go ahead and dilate because it's going to pull this point down towards the, it's going to pull point A prime down towards E, point E, okay, where it's going to pull it towards it. Remember, when you enlarge something, the origin pushes it away. When you reduce something, it pulls it towards the origin. So I can tell right now that if I were to reduce this by 1/3 the size, or dilate it to be 1/3 the size, I'm going to get my points to land where they need to land. A prime's going to land on E, D prime's going to land on H, C prime's going to land on G, B prime's going to land on F. So I'm going to write that down. We're going to dilate with a scale factor of 1/3. And don't just stop at writing that down. actually do the work for showing the points dilating. So right now I've got A prime sitting at 0, 3. I've got B prime sitting at 0, negative 3. I've got C prime at negative 3, negative 3. And I've got D prime at negative 3, positive 3. Let's set ourselves up for dilation. This time we're going to have double primes because it's the second movement. Set yourself up. So now we're ready to dilate. And now all I'm doing is multiplying all these points by 1/3 to get the new points. And if you don't want to have to use a fraction, instead of multiplying by 1/3, you could also divide by 3. These two mean the same thing. Okay, so you can punch in 0 divided by 3, that's 0. 3 divided by 3 is 1. 0 divided by 3 is 0. Negative 3 divided by 3 is negative 1. Then again, both of the C primes are negative 3's, so that's negative 1 and negative 1. And then D, we've got negative 1 and positive 1. Okay, so all I did was divide everything by 3. Now I'm going to check and see if A double prime, B double prime, C double prime, and D double prime are the same thing as E, F, G, and H. Well, read those coordinates. I see E is at 0, 1. That's exactly what A double prime is. I see F is at 0, negative 1. That's exactly what B double prime is. I see G is at negative 1, negative 1. Yep, C prime. And then I've got H prime is at negative 1, 1. Which, yep, that's what we got for D double prime. So our proof as to these two figures being similar is going to be the reflection over x equals 1 and the dilation of 1/3. That's our proof. We checked it. It makes sense. All the points landed where they needed to land. So now let's have you guys give this a try in your U-Try. Please make sure you're asking questions. I know this is a difficult lesson, so make sure you stop, think about the movements you want to make, and ask questions when you're confused. Alright guys, that concludes the lesson, but I want to see what you guys retain from it or if you truly understand what's going on. So here are two close and check questions. The first one says, given trapezoid QRST, draw trapezoid WXYZ that's similar to QRST after a 90 degrees clockwise rotation about the origin, followed by a dilation with center 0, 0 and scale factor of 1/2. The way that I want you to do this is actually do what is written up top here on your actual work page, And then for the Edpuzzle question, when it pauses you, I want you to tell me what is Q prime after you do all of those motions. And actually, let's see, that was 90 degrees rotation followed by a dilation, so you're probably going to be answering what Q double prime is, because there's two movements there. So tell me what Q double prime is, and I'll know that you did this correctly. Then you're going to compare and contrast. How are a pair of congruent figures and a pair of similar figures alike, and how are they different? Go ahead and enter your responses and ask any questions if you need help phrasing your answer to the second close and check question. Well, guys, that concludes our lesson for today. I know it was a difficult one, but keep practicing and keep asking questions when you're confused. Sometimes it's just hard to start the first movement, but don't be afraid to try something, erase, and try something else. So we explained the effect of dilations on two-dimensional figures. We did this by finding the scale factor given a pre-image and an image on a coordinate plane. That helped us figure out how to dilate or where to place the figure. That was in both examples 1 and 2. And then we described the effect a dilation has on an image throughout examples 1 and 2 again. So go ahead and start your homework. And again, make sure, please, please, please be asking questions and getting help when you need it.